All right, good morning, e-learners. So it's Friday, so sometimes Fridays, remember, because we have class at different times. All right, excellent. Well, at least we found each other. Good job. All right, let's get the show on the road.
What is that?
Sierra.
Oh, hi, Sierra.
Sit. All right. Homework, get it out, please. Yes.
I have a question real quick.
Okay, 1 second, Sierra. Yes? Go get it. All right, Sierra, what's your question?
Well, it's for Josie, but.
All right.
So when's the volleyball game? Because I'm trying to go.
It's at 3.
All right.
Yes. Okay, here we go. So hopefully you were able to follow the homework since it was on 2 different pages. It was on the distributive property. Any questions? All right, I'm collecting today, just collecting. I will grade. All right, you're passing out, you're collecting. All right, everyone else. Homework is on the board. Please write it down. Rowan, can you do me a favor? For the new student, could you make sure that he writes this down?
Yeah, he does. Look, I did it.
Okay, and so just so you understand why this is kind of weird, like, hey, why are we jumping around pages? Is because the distributive property, our book decided to do it in 2 different sections. I just wanted to do 1 section of nothing but distributive property and its applications. So last class we did the distributive property. Today we're going to see an application of like when you would use the distributive property, or if you encountered the distributive property, what you would do with it. All right, Rowan, you got him? All right, Rowan's going to help you out. All right, for the rest of us, thank you. We are moving on. So notice what it says. It says the distributive property and combined like terms. All right, so last class was on the distributive property. Today we will still use the distributive property, but we will also do something called combine like terms. Combine like terms. All right, here we go. All right, mechanics. We're going to go over the mechanics of the distributive property real quick. All right, everybody watch the board. All right, chit chat. Chit chat. Thank you. Good job. So the mechanics. Porter, walk me through the mechanics. What am I doing for the distributive property? He said arrow thingy. So I do an arrow thingy. Okay, now what do I do? What am I multiplying? What am I multiplying? You gotta have 2 numbers to multiply. -2 times -3t, right? That's my first one. Okay, so that's -2 times -3t. Then what, Porter? I'm done with my first arrow. Now what? Put my second arrow. What am I doing now? He said -2 times 6. Yay or nay?
Nay.
Yay or nay?
Nay.
What's your mistake, Porter? You said -2 times 6. Is that a 6? It's a -6. The number 1 mistake in the distributive property is you don't use the negatives correctly. In this case, we say he dropped a negative. He literally multiplied by a positive 6 when it's a negative 6. So we need to multiply negative 2 times negative 6. Two negatives make a what, Porter? So what do we get for this multiplication? Talk.
60.
And then for this one? Positive or negative? So put those two together. What do you want me to write? What? You said both answers correctly. Now take the two answers and squish them together. This gives me what? Just 6?
16.
Keep talking. Where are you getting the 21? Okay. What did the math get me right here, Porter? What answer? And what did this give me? So was the 12 positive or negative? So put those two, I don't mean, you got to combine like terms, right? So 6t plus 12. You can't add a 16 and a 12. They're not like terms. Porter, we need to work together. All right, because you don't have this. All right, everyone else, do we think we got this? All right, while I work with Porter, you guys do those three. Go. All right. All right, go. First arrow. What does that give you? Just write what the answer is. Second arrow? What does that give you? Negative 5 times x will be what? 0x minus 5. Boom, look at you. That one's right. Do the next one. We don't need to put plus. We don't need to put any extra signs ever. Just put the signs that are there. Right? When you multiply the first one, you got negative 10. You multiply the second one, you got negative 5x. Negative 5x minus 10. Done. This one first, and then we'll do the next. Yes.
Oh, I didn't know.
You did
Yes.
not.
I'm joking.
The way positive or negative.
This one called me out.
The way you figure out the sign, is what it is. It's negative 5 times 2 is negative 10. That's how we figure out the sign. 3 times 14 is a positive.
Negative
Just
3.
like when that one is so that-
Wait,
Yeah.
Which one are you on?
46.
Yeah.
So you have to do I, B, minus B. Negative
So
You were the missing variable.
Is that negative 3?
Oh, yes, ma'am.
Yeah.
Oh.
Oh, wait.
3's on the outside. One arrow.
And then what? 40 plus 1. 40 plus 8. That's what it would be. I think.
You make us. You're my dad.
Because you have to do 5e minus b, which is 40, and then negative 3e plus 4e, which
This one is
is
weird because the number
1, and 1e is just e. Yeah.
And then follow me.
I remember.
All right, we good? Everybody? All right, Aiden, first one. What's the answer?
10 and 5x.
So 5 times 2, I agree, is 10, but it's not a 5, it's a
Negative.
Negative 5.
10, 5x.
Say it again.
Negative 10 and 5x.
You got to have some symbol in between.
Minus 5x.
Minus 5x. Now, there's two ways to write this, and it really just depends on which number you multiplied first. Aiden multiplied the negative 5 and the 2 first, so his answer was negative 10 minus 5x. I chose to multiply the negative 5 times the x first. Either way is right. So my answer is negative 5x minus 10. He said negative 10 minus 5x. That's the same answer, okay? This is the tricky one, Kaylee. What's the number right here? It is a 1. So don't forget there's a -1 that we're distributing. So, Kaylee, what's your answer? Good Lord, you got it right. Sweet. That's crazy good.
Good job, Kaylee.
This is the one that trips everyone up, right? Because you forget there's a -1 there. All right. Porter, you got the last one? What you got? 9 plus 12C. Very good. Good job. All right. Did anybody put 12C plus 9? Because you could have. Are we good on the distributive property? Because today's class isn't the distributive property. It's something to do with the distributive property. All right. So here we go. In box number 2, Rowan, help him out so he knows what I'm talking about. In box number 2, we need to write down some new words. If you had me for pre-algebra last year, we talked about it. You don't have one? Okay. If you had me for pre-algebra, we talked about this before, but for many of you, these might be brand new words. Brand new words. All right. Write this down in yellow. Write this down in yellow, box 2. You are what we call a term. If you're a number, write this down, Ryan. If you're a number, a variable, or the multiplication of those two things. So it says the product of a number and a variable that are separated by addition or subtraction. That's a whole lot of mess going on there. I will explain it. A term is called a number, comma, or a variable, comma, or a product of a number and a variable. Sounds complicated. It is. That are separated by addition or subtraction. A lot to write there. Math teachers say this all the time. Look at the term. Look at the term. You're like, what are they talking about? So from now on, from Algebra 1 onward, we'll say, look at the middle term. Look at the first term. Look at the last term. Look at the third term. Look at the first term. Here's what we mean. The key to this is looking at the very last 2 words. What are the last 2 words?
Addition and subtraction.
When you see addition or subtraction, that's what separates terms. Addition and subtraction separates terms. Hey, do you see addition or subtraction? Yeah, so there's a term here and there's a term here. That's what it means. Because it says a number, well, that's a number. Or a variable, there's no variables here, but there is a product of a number and a variable. The easiest way to remember terms is to look for a plus or a minus. I got a plus. That means there's a term over here, left side, and there's a term over here, right side. I got 2 terms. That's what a term means. I will use this all the time from now on. Hey, look at that term. Okay. Write this down also in box 2. A constant. Right, Porter? A constant is just a number, except it says a term with no variable. It's a number all by itself. It's a number all by itself. Is that water or food? Okay, that's fine. I'd be doing the same thing if I had ice. So, is there a constant here?
Yes.
Which is the constant?
6.
Just 6, because it's lonesome. It has no buddies.
I feel that.
We're not done with vocabulary yet. We got one more. You see this term, the first one right here? This one has a number and a variable. When you have a term that has a number and a variable, the number gets its own special name. It's called a coefficient. A coefficient is the number in front of a variable. That means to the left of the variable, the number. All variables have a coefficient. Even a variable that doesn't have a coefficient, like x, has a coefficient. What's the coefficient of x? 1, because 1 times x is x. The multiplicative property of 1 states that 1 times anything is itself. We just choose not to write the 1. So we're going to be talking this entire year about terms, constants, and coefficients. We get to solving quadratics. I'll say, hey, look at the constant term. I'll say, look at the first term. I'll say, look at the middle term. I'll say, what's the coefficient of the middle term? All of that should make no sense to you except for the word term, constant, and coefficient. Do you have these written down?
Yes.
You will have to identify these things.
Today?
Not too hard to do. So I have an expression here, 3x plus 6. How many terms do I have here? How many terms?
Two.
Terms are separated by addition or subtraction. So how many terms do I have here? Those, the first one and the second one. So you can either call them both terms, or you can be more descriptive. You can say first term, second term. First term, last term. If there was 3 of them, I could say the middle term. Terms just mean things that are separated by addition or subtraction. We okay? What's the coefficient here? 3 is the coefficient of x. Okay, so 3 is the coefficient and 6 is a constant. Could you do that all by yourself? Identify that? Okay. All right, we got to talk about simplifying. You're like, well, we've already done this. That's just PEMDAS, right? Simplifying, follow the rules of PEMDAS, use the distributive property if necessary. We know how to do that. It turns out there's more to simplifying than just PEMDAS. Because now we're going to throw in variables, box 3, write this down, like terms. Okay, terms are separated by addition and subtraction. Like terms are terms that have same variable factors. I see a whole bunch of people, the pencils are not moving. Aiden, Rylan, write this down. Like terms are terms that have the same variable factors. A lot of fancy words there, I'll explain them. Same variable factors. Now, the explanation that I give you will not be in a math book. They'll just say same variable factors. What are you, stupid? You don't know this? Right? So I'm going to do it. Well, I'm not going to do it the stupid way. I'm just going to give it an easy way. Here's what it means. It means you have to have the same variable and the exponent has to be the same if you're a like term. And if you need it even simpler than that, letters with letters, numbers with numbers. You can combine same letters with same letters, and you always can combine numbers with numbers. The issue is the exponent. You're going to have lots of exponents tonight for homework or over the weekend for homework. The only time you can group them together is when the exponents are the same. Great, I got an x and an x to the 4th power. You can't do anything with them. Well, I should say you can't add or subtract them. Turns out you can multiply them, but you can't add or subtract them. The only time that you can combine like terms, that means adding or subtracting, is when the variables match up and the exponents match up. You saw a little bit of this last year. This year, it comes at you like a freight train. We'll spend the entire year doing what's called combining like terms. There will not be almost any algebra problem where you don't combine like terms. You okay? Have everything written down?
Yep.
All right. So I'm going to leave this up. Same variable and exponent we can combine. So here we go. A big honking thing. I'm even going to give you a name for this in a few classes. Do you know the name for this expression? What it is? Yeah. Brandy, do you know the name of it? Does anyone know the name of it? Okay, good. Then I will teach all of you something new this year.
What?
This is actually a quadratic trinomial. But
Yeah, I don't know.
Okay, I know what the word quadratic is, but I don't know what.
All right. But more on that later, not this class. Okay, so our job here is to, well, it looks like we're supposed to add and subtract a few things, right? But like terms are the only things that we can group by addition or subtraction. So we need to figure out, do we have like terms? Piper, we're only looking at letters. What's the letter? To the what power? Is there any other a to the 2nd power? It has no friends. It stays by itself. All right. The next one, what do you see? Are there any other b's to what power is this one? There's no power. Do you remember if there's no power, we put it to the 1st power. So this is really b to the 1st power. Are there any other b's to the 1st? B has some friends, right? The b's, right, we can combine with other b's. But you can only combine b to the 1st with b to the 1st. I've got 2 of them. and then we got a constant term. You see that? So the only thing we can group together are these. I don't know what color that is. It looks pinkish. All right, the pink ones. Salmon? All right, the rule is this. To combine like terms, are you listening? We look at the coefficients. We look at the coefficients and we do whatever it says. What does that say?
Negative.
Plus 3. It says -5 plus 3. Oh, that's what we just did the other day.
2B.
What's -5 plus 3b, and don't say 2b? The answer is -2b. So we combine the coefficients of like terms. So -5 plus 3 is -2. And that's what it turns into, because the constant doesn't have any friends. And, well, soon to be, you'll learn this is called the quadratic term doesn't have any friends either. Okay. Doesn't sound like it's too hard, right? And it's not. They're going to give you some long expressions. You're still going to do it the same way. Tristan, you're up. Does x squared have any friends?
Yes.
Oh, yeah. First one in the... He's pointing the right way. First term in the
Left. Right.
last term.
Last term. Sorry.
The first term and the last term. Okay. Does AB have any friends?
Yes.
Which ones?
Middle term.
The two middle terms, right? They have friends. So we can combine, I don't know what color that is. We combine these.
Green.
Is it green?
Pukish green. Like.
I see none of that.
It's that weird yellow. Green.
Well, I can see that this is yellow. So we can combine yellows with yellows and puke green with puke green. If that's, my puke doesn't look like that. All right. How do we combine like terms? What do? We look at their coefficients.
So.
This
2
one's
plus 5 plus
easy.
3.
What's the coefficient?
2.
Well, what's the coefficient over here?
-1.
-1. So just remember that has that magical 1 right there. So what's 2 minus 1? 1. And then what was its x squared? So 1x squared. Do we need to write the 1?
No.
So we could just write.
X squared.
And then what are these grouped to?
8
Say it.
AB
8ab. So this turns into x squared.
less 8AB.
Who is lost?
It's so easy.
You tell me. Is this easy, medium, or hard skill?
Easy.
Where are you going to make your mistake? There's 2 ways to make the mistake. Where are you going to make your mistake? Well, hopefully. Where are you going to make your mistake, Julie? I can see 2 ways to make a mistake here. What's the obvious way you'd make a mistake? Yeah, you just added and subtract wrong. You do 5 plus 3, and I don't know, you write 15 because you're not thinking. The second mistake is this. You see this x squared, right? And it might be just an x. And all of a sudden, you won't be paying attention, and you'll group an x squared with an x. Those are the 2 mistakes. Either you make a calculation error, or you combine what's called non-like terms. Those are the 2 ways you make a mistake. But on the level of, is this hard or challenging? This is on the easy scale. Julie? We'll talk about it here in a second. Like that. Okay? By the way, this is box 4. What? Does it say 4A?
Yes.
All right.
It just says 4, but I guess 4.
All right, here we go. Now I'm going to put another one down here. Does 5 have any friends?
6.
6. We can always combine the constants. So what's 5 plus 6? Well, that was easy. Does -3x have any friends? Does y have any friends? So what's the answer?
11.
Very good. Very good.
It's so mumbly.
Well, I heard they all said the same thing. 11 minus 3x plus y. Who's lost?
Not me.
Good, because this is basic skill stuff. Well, no one said they were lost.
Well, what
No,
if
someone
someone
did
thought
do
they
it.
were
Wow,
lost
it's
and like,
basic
oh crap.
skill.
Then you need to be a brave student and say, I'm lost. Right?
After you saying that, I wouldn't raise my hand.
Well, no one raised their hand at first. So, I mean, you just, okay, let's get over it. We all got to be brave. You see me make mistakes in class, so you're going to make mistakes. If there's something you don't understand, and I'm not doing my job explaining it, so just ask me, I'll say it a different way, or maybe I'll yell louder, right? 1 of the 2.
Too late.
All right. All right. Does -7h have any friends?
No.
Which one? All right, so I can combine
Oh, I
that
have
one and
two.
that one. So remember what I said my 2 mistakes were. is that you either calculation error or you won't see what to group together. I'm still going to claim, Josie, that this is a pretty, to know what to do is the easy part. To actually do it is where the mistakes come in. But does h squared have any friends? Does -3 have any friends? So the only thing I'm grouping are these two. Group them. So this is where that second error comes in. Now all of a sudden, you forget the rule. You forget the rules of subtraction. Hey, let's just go over it. Same or different? Same or different? The same mean add or subtract. So that's, and then you forget to tack on a -11, or tack on the negative. So yeah, it's -11. All right, that isn't bad. You guys are killing this. Killing. Oh, by the way, I mean, think of where we've come like 2 years ago. 2 years ago, if I'd have shown you this, you would all been pooping your pants, right? If I show this to 7th graders, they would have a conniption, right? As 9th graders, you're looking at this, you're like, whatever, right? It's easy.
Cry a lot.
I've already had many people cry in class.
Over math?
I should not share this because this is being recorded, but I'll do it anyway. The other day in class, right?
I'll reenact it.
You guys remember doing consecutive numbers?
Yes.
Give me 3 consecutive numbers, any 3.
1, 2, 3.
So literally, that's the ones they picked. So 1, 2, 3. And so I said, okay, how did we get from 1 to 2? How do we get from 2 to 3? So they all said that. And then when I said, okay, so here's the deal. The first number is not 1 anymore, it's x. So how do we get to the next consecutive number? You just add 1. How do you get to the next consecutive number? And I had a girl cry over that. Because, so the issue was, no, I didn't laugh at her like you are, but the issue is this: in 7th grade, that's when you're first confronted with this thing called algebra. And the fact that you have variables that represent numbers. She literally was, I mean, she's a great student, but she wasn't getting it immediately, and it was causing her fits that she couldn't understand immediately. So yeah, there's tears. By 9th grade, you guys are all jaded, and I get no tears. Yes,
Yeah, I remember.
exactly.
That was my dad was torture.
And then your parents yell at you louder.
What? 3
I did the same thing with my kids. Okay, back on track here, up here. And no, I'm not going to tell you who's crying, but that's the story. Here on box 5, you got 4 problems. Do them, please. On box 5, 4 problems. Do them, please.
I remember my mom yelling at me, like, I never knew division. She was like, it's easy.
Yeah.
What? 3 times 3.
There's something about when your offspring, I mean, my wife's an accountant, and she doesn't have a math degree, she has an accounting degree. So she's good at math, I'm good at math. The older daughter, straight A student, she's good at math. The younger daughter is really good at math. She's going to an engineering school right now, in fact. But I just remember it was the same thing, is that, you know, I literally had the feeling of a tinge of anger, you know, with a huge thing of frustration when she would have problems with math. And I was like, how? You are my daughter. How could you not understand this?
I just never see my paper through the
You were-
tears. I know.
Parents make some parents make great teachers, but I know I was one of the worst ones. I was about to say parents make the worst teachers, but it's not always.
Some parents.
Some parents.
My mom
Myself
tried her
included.
best, but like I feel bad because
Shoot 'em up.
she came home from holiday, so she had to deal with it. So she had
And they had to deal with you.
a little 5-year-old to be like, I don't know what it is.
Are you doing this?
And,
Yeah.
and she couldn't say go to yourself.
Yeah. You're just,
Do it yourself.
Show me. That's what I thought, 'cause I was almost finished and I had to.
All right, is anybody struggling with this?
Josie is.
no.
No,
Josie
I'm not
is not
struggling
struggling
with
with this.
Josie, which
I am on.
The times when Josie struggles with something, she lets me know. Because Josie is a brave student.
what's it like?
No, she's not afraid. When she doesn't get anything, she will very clearly say, Kaylee's the same way. She's a brave student. She won't. I mean, granted, there is an embarrassment factor, certainly, but you just got to get over that in math, right?
I don't get it with the squaring.
What do you mean?
What's x squared?
Oh, he said swearing. I was
Swear.
like,
So it's a variable multiplied by itself. That's
So 2.
yeah, but remember, we're not throwing any we're not doing any evaluation today. We're just combining like terms.
Oh.
All right, Aiden, first one. What's the answer?
I got 3 minus x.
I got
Okay,
3x.
so the rule is this: x is to what power?
Actually, no, first.
Okay. Does it have any other x's to the first power? When that's true, you just simply take the numbers, the coefficients, and you do what it says. What does it say to do?
7 minus 4 is 3.
So you tackle on an x, and you're done. So the answer is 3x. I do. So what we're doing is I'm combining a 7x and a minus 4x. In other words, from 7x, I'm subtracting 4x. It's just a math where we say combine like terms. It literally just means take the terms that are like each other and group them together. Agreed. And grouping together, remember, is also can be called subtraction. You want the second one?
Yes.
What do you got?
7d plus 6.
Because 5 minus 2 is 7.
It was negative 2 plus 5.
Okay.
What's negative 2 plus 5?
What's negative 2 plus 5? Same or different signs? Add or subtract? So subtract the numbers. We don't get 7, we get
3.
more negatives, more positives.
Positive.
So the answer is,
3d plus 6.
there we go.
3d
Okay,
plus 6.
take a pause here and do that one more time. Did you hear what he said? He said the answer was 70. What did I do as the teacher? What did I do as a teacher? I didn't help him in the sense of, I'm saying I made the speech the other day.
You asked
What
me 2
did
questions.
I asked him the same questions? This was the thing I said I want you to be able to do to yourself. All I ever do, and the claim I made the other day is every time I do this, kids get it right immediately. But all I did was say this: same or different signs, add or subtract, more negatives, more positives. That's the only thing I ever say. And I have yet to have a student get it wrong. Yet I have students get it wrong all the time, like just happened here. And then all I do was just simply say those 3 things: same or different, add or subtract, more negatives, more positives. My claim is that if you were to do that yourself, you would never make a mistake. Because I have yet to have a student, if I say that, get it wrong. Not once did I tell them what the answer was. Not once did I say yes or no. I just said those 3 things. Yeah.
Or it could be you teacher and then very other students come up here late, but
Well, the other thing too is that I will not say those 3 things to someone who gets it right. So I agree with the fact that he already knew he got it wrong. So he was going to change his thought. But I'm saying, okay, great. If he had said that to himself, I think he would have said immediately different. I got to subtract. All right. And oh, by the way, I've made that mistake plenty of times myself, included. All right. Who wants the next one? Go.
Isn't lunch?
No.
4x squared plus 5x plus 4.
So the only like terms on this third one is what? Or are what? 2x and a 3x, and that's 5x. So that's good job. We okay? Piper, you want the last one? Sure you do. What's the exponent? What's just the exponent? The exponent is small number 2. Are there any exponents here that have a 2 on it that are also an x? That one.
You got it.
Coefficients are the numbers in front of the letters. So what are the numbers in front of the letters? And what's the number here? Hold on, we're almost done. And a 1. So when we combine the like terms, we stop. When we combine the like terms, we just look at the coefficients and we do what it says. What does it say? What's 3 minus 1? So 2x squared plus 2x. Who's lost? Do we feel confident to do the homework?
Yeah.
Has anyone finished the homework?
Right now.
Is there anything I left off?
I don't think so.
All right. Why is what 2? Because what's 3 minus 1? We okay? Yes, Julie. Hey, time out. I can't hear her if you're talking. Aiden. Go ahead, Julie. Yeah? So, everybody look up here and then I'll stop talking. Hey, what's your first step? As you're looking at it, what's your first step? Distributive property, yes?
Yes.
So I got 1, 2 things here. I'm going to use the distributive property, and I get that. And then we take this and we can see what are the like terms. Julie, what are the like terms? There's a y. Are any more y's? But there is a -6 plus 5. Julie, -6 plus 5. Positive or negative? There's your answer. Yes. Let's see. These ones get really, 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 really messy, but it's still the same thing.
It's really
Do the
easy.
distributive property and then combine like terms. So there's your homework. All right, go get your lunch. You need to go get your lunch. We're eating lunch in here, so somebody take charge just in case. All right, guys, e-learners, what are you guys eating for lunch?
It's
You're on
only
mute.
me, but like, I'm probably not gonna eat lunch because now I have to like hurry up to be able to get to go to the volleyball game.
You got 3 hours.
I know, but I have so much stuff to do.
All right. Well, you also have 3 days, right?
What?
Well, if you're talking about schoolwork, well, I'm saying you got 3 days, Friday,
Yeah,
Saturday,
I
Sunday.
have to go and do like stuff with my parents.
Oh, all right.
And we're moving right
Yeah.
now, so like,
All right. Well, you enjoy that stuff with your parents, and you're coming to the evening. What time is the volleyball game?
3.
Darn it, teacher's got a meeting at 3.
I'm gonna try to, but
All right. All right. Well, if I see you, I see you. If not, have a good weekend.
all right.
See you.